Let's dive in. All right, so again, if you had trouble with graphing calculator, feel free to hang out after class. Be glad to help you with that if you had trouble with some of those, or before class, either way. All right, so how do we do the logarithm base 5 of 625? You guys keeping up with all this homework stuff? I'm glad to see a group of you down there getting help. You know, really, math and science, math especially, probably, yeah, math and science, well, it's about doing that homework. It just is about learning the concepts as you go. Really encourage you to keep up with the homework. You can pass this class. You can get an A or a B in this class just doing your homework regularly. That's just really it. Let me practice exams, which will be just like it too. All right, log base 5, 6, 25. Basically, to do these, you just turn them into 2 logs on your calculator. Yeah, let me give a little precursor information. Do you realize that the button that you have in your calculator, is got no base showing? Like if I did log 625, for example, you guys have a log button on your calculator, right? You guys have that? That one, it just says log. It doesn't show a base. Do you know what? And did we mention this briefly last time? Base is 10, right? Base is 10. So that button that doesn't show a base in your calculator, the LOG log word, its base is 10. Well, you think, well, this is base 5. How am I gonna do that? Well, so if the base is anything other than 10, you make it 2 logs, like that. So let me write, when base is not 10, do 2 logs. So when the base is not 10, do 2 logs. So log base 5 of 625, just go ahead and turn it into 2 logs on your calculator. Log 625 over log 5, like that. Make it 2 logs on your calculator. And just hit the buttons. Is it 4? Yeah. Is it 4? Okay, 4. I think it's 4. Is that good? Oh, the clickers are in. Did I mention that? The clickers, I did? Mm-hmm. I mean, they're for sure in. I think I said they would probably be. They were. I got an email yesterday from Barbara Mendoza.
Yesterday.
Good, you found them, yeah. So we'll start on Tuesday. So clickers. Clicker quiz, our first clicker quiz will be Tuesday. So on Tuesday, make sure you have your clickers with you. Do you know, did I mention how to register for those? Okay, so, all right, let's try this. So that was 2 logs, log 625 over log 5. On that, you guys getting that? Want to, again, bring your calculator with you to class so we can do these things. Is that all good? Let's try another one. Okay, let's try that one. So log base 3 of 81. So is that a log of base 10? No, so we have to do 2 logs on our calculator, huh? Everybody getting the plan there? When the base is not 10, because all your calculator can do in one step anyway is base 10. So if it's different base, you got to do 2 logs. Base not 10, do 2 logs. Now, good question students have asked me over the years is they've said, Mr., how do you know which one goes top and bottom? Because the 3 comes first, that top, bottom. What I learned to say to people after a while is the high one goes high, the low one goes low. So with the base one, the bottom one goes to the bottom. So the higher one goes to the top, and the lower one goes to the bottom. So just type that into your calculator, and the answer is 4. That's the great thing about these logs. It's always 4. The answer is always 4. I'm just kidding. It's not always 4. But we had 2 in a row. It's 4. Is that good on that? If you're interested, if you know more about logs, that's the power on 3 that would become 81. 3 to the 4th power is 81. That's what logs really ask. Power needed on the 3 to become 81. Well, it needs a 4th power. That's what logs are. They're a reverse power question. But anyway, you don't need to know all that. We'll just crank them out. Logs are a reverse power question. They really are. Questions on that? Is that okay? Getting that in your calculator? Especially calculator stuff. Just grab me after once you get the hang of the calculator stuff. So log base 3, 127. Same thing. Hit the buttons on your calculator. The higher one goes high. The low one goes low. So it'd be log of 127 over log of 3. Good there, and I think this one comes out negative 3? Yeah. I don't know if you know the rules, power rules really well. You could just figure it out. 3 to what power is 127? 3 to the 3rd is 27, and what makes it flip is the negative 3. Anyway, you don't need to know all that. You can just hit the buttons on the calculator. That's why it's negative 3, because that's the power on a 3 that'll make it flip. Negative powers make things flip. I don't know if you remember that from algebra. That's why it's -3. Anyway, calculator will tell you. Good on that. All right. So let's try that one. Log 14. When I hit the buttons, I'll do it too. Get 4. That's just a straight single thing. So I'm getting 1.1461 rounded to 4 decimal places. Good on that. Log 14. That's all they want. We'll keep moving. Now we got to deal with the actual properties. So I think what I'm going to do is so 3 log properties. Number 1, the log base b of x times y. So log base b of x plus log base b of y, and the log base b of x minus the log base. Oh, whoops, doing it in the wrong order. Of x over y. So dividing. So notice multiplying becomes adding, dividing becomes subtraction. And the third property, log base b of x to a power, that power can come down to the front. Like that. Okay. So those are really important properties of logs. They have those qualities. If I can spend just a minute, you get a 3x5 card for the exam, so you don't have to memorize them. But if so you put them on a 3x5 card for the first exam. But if I can kind of point some stuff out and make them a little more familiar to you, even though you don't have to memorize them, it might help. So first off, notice they all have the B, right? That's not changing. We're not doing anything with the B. The B is kind of like glued to the G, right? That's just the base. We're not messing with the base. All we're changing is the X and the Y. And so what happens? Well, basically, remember the order of operations? Please excuse me, dear Aunt Sally kind of thing? Remember that? Parentheses, exponents. You can think about it this way. Logs bring everybody down a level in the order of operations. The order of operations are almost the order in which you learn things. Remember the first math thing you ever did when you were a youngin'? First grade, kindergarten, you added and subtracted. Those were the days, huh, when math wasn't too bad. Added, subtracted. Then later on, got older, multiplying, dividing, exponents, powers, and higher things. Okay, well, that's the order of operations, and that's what the logs do. The logs basically bring everybody down a level. If you notice what the properties are doing. Times becomes what? Adding. See, multiplying drops down to adding. And dividing drops down to subtraction. And here, powers become what? Multiply. Powers, exponents, this is exponents, which means powers, like 2 to the third and stuff, come down to multiply. See how they bring everybody down a level in the order of operations? That's basically what they do. And not only that, you can tell which way they do that. The easier operation is for 2 logs, the harder one for 1 log. It's like the old saying. Have you heard that old saying? Many hands make the job lighter. Like a lot of people are doing a job. Like I helped somebody move maybe a couple months ago, and I lifted, I think it was a 700-pound table. I don't know why my friends have a 700-pound table, but I heard that's what it was. But I didn't lift it alone. I hope you were impressed for a second. But it was me and like 4 or 5 other guys, and we were all around it. And we lifted together, so we could all do it together. So that help you memorize the logs. So for the 2 logs, it's just adding. That's easy, huh? 1 log, it's times a little harder, higher operation. So it's always the higher one for 1 log becomes the easier one for 2 logs. Dividing. Higher operation just becomes subtraction. Becomes easier for 2 logs. So and then the bottom one is just 1 log to 1 log, so he's different. But for the first 2 properties, it's always the harder operation to the easier for 2. It's like job's easier for 2 people than 1. So that's just a way to help you kind of get familiar with those log properties. So let's actually do the question now. So what are they saying? So they're saying subtraction for 2 logs. That's it. So adding, subtracting, that's a real easy operation, right? Subtracting for 2 logs is going to become a harder job for only 1 log. And they're telling me to make it a single log, aren't they? Change it to be only 1 log, and all the answers are only 1 log. So what's it going to be? Subtraction is going to become dividing, huh? And by the way, subtraction and dividing go together because they both make things smaller, don't they? Subtracting, dividing. Whereas multiplying and adding go together, they both both make things bigger. So there it is. So which answer is that? A?
C.
C? What's wrong with A? Oh, yeah, C's upside down. A's upside down. It's C, you're right. There we go. Yeah, the order matters. Good. Good so far? Okay, so we have 4 log base C of x minus log base C of y. So they want me to, see how they say single logs? They want me to make it, crunch those together and make just one log. My goal in the end is have one log. And I'll just put the base C right now. We never mess with the base. That's for sure going to be there. It's just about the 4, the x, and the y. What are they going to do? Well, that 4, do you know, he's going to go up to the power. Remember that third property, if I go back here? That third property that said powers can go from the front to the power, from the power to the front, either one, either way. So I'll put that up here. It'll be x to the 4th. And then what is the subtraction going to become? Division. A harder job for one log. Dividing is harder than subtracting, right? Harder job for one log. Like that. We good there? Questions on that one? Okay, so now log x to the, is that 9? Yeah, it's awful tiny. Y to the 7. And now they want us to rewrite it as a sum or difference of multiple logs. So they want me to go from one log to lots of logs. We're basically running these properties back and forth is what we're doing. So now they want me to go from one log to many logs. Can you do that? Can you make that more than one log? So it's times in here, isn't it? The 9 and the 7, they're just going to end up being in the front, right? Powers end up coming to the front. So it's going to be 9 log, and there's no base on this one, which is fine, x plus 7 log y. Does that make sense? See why it's plus? Because it's times. So it becomes an easier operation, just adding for 2 logs. Harder for one.
It would be log of x 9 plus log of y 7. Why wouldn't it be?
You mean like the 9 up here still?
Yeah, and 7.
Yeah, that's actually not wrong. They just want you to do one more step where they want the power to also come down.
So both properties.
Yeah, both properties, yeah. Yeah, and they say it right here. Here's how they say it. They say without exponents, no powers. Yeah, so they want those powers down in the front on that. Good. Other questions on that one? Good. All right. Okay, so now they're giving me log 2. I should have made that bigger. Well, let's write it bigger. 2y over z. And they want us to break that apart into lots of logs. So try that one. Break that apart. It's going to become 3 logs, as you can tell. So the log base 2, that's not going anywhere, huh? They're going to all have the base 2 there. And then anything in the numerator, like a 2 times y, those will be added, won't they? And the z in the denominator will be subtracted. Because dividing is subtraction, multiplying is adding. And there we go, whichever one that is. This making sense? Do you remember this kind of from your algebra days? Sort of, kind of? All right. So I'll move on. Okay, so log base, what is that, 36? Yeah, 36 of 3, 3, 4. Yeah, so if it's just all numbers, then that's just hit the buttons on your calculator. So the high, remember the high one goes high, and the low one goes low. So that's just what we were doing at the start of the hour. Just whatever that becomes. On that, I'll do that too. So the high one goes high, the low one goes low. I'm getting 2.2646. Oh, 6 decimal places. Oh boy. 2.26459. Oops. 9581. They want me to round to 6 decimals. So 1, 2, 3, 4, 5, 6. This is the 6. You circle the place you're supposed to stop at, and you look 1 to the right. If it's 5 or more, you know you go up. 6, 4, 5, 9, 6, huh? There we go. Good. Just hit the buttons. Logarithms from algebra. Okay, so how do you graph these things? So y is natural log of x plus 2. How do I graph that thing? Well, let's give it a try. So what I'm going to suggest will be the easiest way. Yeah, let's just plug in a couple points. Let's just plug in a couple points and put some dots on the graph and just kind of connect the dots. So when I'm just making tables, I'll just start with 0. Just plug in 0 there. Just use my calculator. So y is natural log of 0 plus 2, which is natural log of 2. And what is that? What's natural log of 2? 0.69. I'm just going to round it to 0.7 because I can't really graph any more accurate than, 0.7. I can't tell 0.7 from 0.69. Good so far. I'm just putting in 0. Now let me put in 1. Natural log of 1 plus 3, which is natural log of 4. Oh, wait, why did I do 3? That's not right. 1 plus 2, huh? I don't know if that's going to be much higher. I guess it is. I'm getting 1.1 when I rounded it. 1.1. Plug in 2. Natural log of 2 plus 2. Natural log of 4. I'm getting 1.4. So it's slowly going up. It's good to do a couple negatives also. So let's do -1 and -2. If you do -1, you get -1 plus 2. Natural log of 1, your calculator will tell you that's 0. And if you plug in -2, you get natural log of 0, which the calculator will tell you is an error. That's a no. Is that okay so far? So I just plugged in some easy numbers. I just plugged in 0, 1, and 2, -1 and -2. So just plug in 0, 1, and 2, -1 and -2. And put them on the graph. Okay. And now let's see what our graph looks like. So here's 1, 2, -1, -2. And 1, 2. So over 0, up 0.7. Over 0, up 0.7. About like there, That good so far? Over 0, up 0.7. Over 1, up 1.1. About right here. Over 2, up 1.4. Is that good so far? Connecting those dots. And now back 1, up 0 right here. And then back 2, no. So that means the graph doesn't go there. The graph seems to go forever to the right. I'll just put an arrow there. Seems like it's having no trouble going to the right. But do you know what a log graph does where you hit the no wall? That means it actually takes a dive right at that wall. Like that. Log graphs always have one spot where they either take a dive or they go up real fast, one or the other. There's actually a vertical asymptote there. We're not going to get into all that. You don't have to worry about that. But that's what's happening. It hits a wall there. You can't do that. You can't logs. You can't have 0 or negative inside any log. Try it in calculator if you want. Natural log or even the regular log, log, either one. If you do 0 or negative, it'll go error. So you can't make the inside of any log 0 or negative. It just won't allow it. If you put in negative, if you did anything over here would all be no. This is all no territory. If you plug in your calculator any of those values, it'll give you error. So that's where it takes a dive. So which one of those is the right graph?
D.
A and D look close. How do you know? They're pretty close. A and D. I'm going to see how in the middle right here, that's just under 1. Here's 1. In the middle, it's supposed to be under 1, and it's supposed to go down at -2. So I had to kind of push hard on that to find which one. A and D were very similar. Let's try this one. Log, so y equals log of x plus 7. It's, you know what, I probably better move on. Yeah, it's just the same thing. It's plug in points. I'm going to go dot, dot, dot. Make an xy table, and I plug in 0, 1, 2, -1, -2. See how I make my tables? 0, 1, 2, -1, -2. Just plug in there, find some dots, find the right answer, but it's just a plug in, I think. Okay, so they give me this fancy function, and they say gives the number of years required to double your money when it's invested interest rate R, expressed as a decimal. That's important. So then they say, all right, find out how long, 4%. So in part A, they give me 4%. What that means is plug in 0.04 to that formula. So natural log 2 over natural log 1 plus R, that's the formula. Plug in the 0.04 right there. And just hit the buttons on your calculator. That's all it really is. It's just a plug-in. I'm getting 17.6. How far do they want me to round? Hundredths. I get 672 hundredths. They tell me round to the hundredths right here. Hundredth. That's 2 places. So you circle the second place. Look 1 to the right. If it's less than 5, you just leave it. So 17.67. How we doing? So I just plug in. So that's what you do part B, part C, part D. Just plug in. And then part E is talking to you about the rule of 72. Yeah. This rule is called the rule of 72. You guys ever heard of the rule of 72? Going into business? It's kind of a famous rule among investors. The rule of 72 is what they're going to point to in part E. The rule of 72 basically says if 2 numbers multiply to equal 72, you know, like 9 times 8 or 6 times 12 or whatever, that'll double your money. That'll double your money if one is percentage and the other is the years. So in other words, if you go, since 9 times 8 is 72, if you invest money at 9% interest for 8 years, or vice versa, 8% interest for 9 years, or maybe I said the same thing twice. I don't know, whatever. Either way, 9 and 8. If 9 and 8 are your interest rate in your years, it's really close to doubling your money. Any 2 numbers that multiply to be 72, like 6 times 12, 9 times 8, 2 times 36, right? Any 2 numbers that multiply to be 72, if one of those is the percentage and the other is the years, if you only had a 2% interest account, that's pretty low, but you invested for 36 years, you'd double your money. Pretty close, because they multiply to be 72. It's a rule that Gauss, a real great mathematician, discovered. So they call it the rule of 72. Any 2 numbers that multiply to be 72, if one of those is the interest and the other is the years, that's pretty close to how long and what interest it'll take to double your money in an investment. It's the doubling your money rule, rule of 72. I think it's mostly just plugging in here. Let's see. So x equals, remember how they always do time and they always pick different numbers for time? They're doing that here. They're saying x equals 1 is 2001. So in other words, x equals 2 would be 2002, etc. They always make new numbers for the time because they don't want us to plug in numbers in their thousands. They want to make it simpler. Okay, so estimate sales in 2006. So how am I going to find out sales in 2006? I'm going to let x be 6, and just plug it into the formula, this formula right here. So 10.457 plus 3.61 natural log x. So I'll just plug the 6 in there. Oops, getting kind of scribbly. 10.457 plus 3.61 natural log 6. And then just hit the buttons on your calculator. Same thing for 2008. Graph the function for that. Assuming that this model remains accurate, what does the shape of the graph suggest? I don't know. You just look at the graph and it'll say something. If it's going up or going down or leveling off or something like that, you'll be able to use the help button on here, the question help, if you're at all confused. when you graph, on part B, when you graph, let me write some stuff out for you on that. When you graph on part B, it says graph it from 2001 to 2025. That means you're going to go from 1 to 25 on your x. So your x min will be 1. Your x max will be 25 on your window settings. Is that making sense? Do you know what they mean with the, are you getting the hang of the graphing calculator? That's where I'd be glad to help you. Hang out after for a minute or come before. Next time, you know, you okay on that? When the graphing calculator, when you set the window, if they tell you to graph from here to there, you know, it said 2001 to 2025, then you let x min be 1, x max be 25 on your window settings, and then put the function into y1. So y1 will equal this function. So 10.457 plus 3.61 natural log x. So yeah, put that into y1 and then x min, x max, graph it. And what if you graph it and you can't see anything? That's the main point I really want to help you with so that nobody is confused by that on the exam. Whenever you graph, if the graph is blank, if you're getting nothing on the graph, what button on your TI should you hit to help find out where that graph is and why it's not showing up in your current window? There probably is some other buttons too. I suggested table. Hitting second table, which is up in the top. There's probably other ways too. Trace might work too. Second table, because that'll show you like where the Y values are. Specifically, look for the Y values and adjust your Y window to cover those. Now, I'm hoping that makes some sense to you on that. Maybe it'd be valuable to actually do. Okay, so total assets. Okay, so notice what they're saying. Can you do part A? Find the total assets in the year 2001. Can you guys read that? Let me write that for you bigger. F of x is minus 2.06 plus 1.424 natural log x. So there's the function, and they're saying, notice this over here. X equals 10 is 2,000. Okay? And they want to know in 2001 what it equals. Can you do that first off? Use your calculator. Don't need to graph it. We'll graph in part B. This one's a plug-in. So what am I going to plug into my calculator? For x, I mean. Good, 11. Is everybody seeing it's 11? Because they made 2000 be 10, so 11 then is 2001, which is what they want me to do. They want me to plug in x as 11 right there. So negative 2.06 plus 1.424 natural log 11. Is that good? So whatever that comes out to be. I'm getting 1.3. How many places they want? Thousandth. So 1.3546. Thousandth place means, 1,000 has 3 zeros, so that's 3 decimal places. You circle the third spot. We're going to end in the thousandths place, third spot. Look 1 to the right. If the 1 to the right is 5 or more, which it is, it's 6. Round up, huh? 1.355? Did you guys get that okay? Anybody else getting that? Yeah, okay. That's part A. I wanted to do part B with you. Now part B, they want you to type that function, this function right here. Type this into Y1 and graph it. We good so far? We're doing okay? So type that into Y1. And notice part B says if this model, blah, 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 find the year total assets are what is it, 225? Yeah, 225. Total assets are 225. Was this millions or something? Trillions. Okay, 225 trillion. So 225. So, or not 200 trillion, 2.25 trillion. Anyway, whatever, 2.25. So that just means let y2 be 2.25, let y1 be this, or vice versa. It doesn't matter which one's y1, which one's i2. Doesn't matter at all. Graph them both and see where they intersect. Find intersection. Intersection. Is that good? Is that making sense? Can you do that real quick? I want to make sure you can do that. So type in y1 in your graphing calculator. Let y2 be 2.25 because they want it to equal 2.25. They want that to be f. Right? So remember when you try to solve these really difficult equations, you can just let y1 be one side, y2 be the other side, or vice versa. The order doesn't matter. Graph them, and then adjust your window using your y value. See if you're getting the hang of that. And remember, negative signs are different than subtraction. Remember, the calculator gets really bent out of shape. Use negative with the parentheses around it when there's a negative instead of a subtraction. It'll give you syntax. If you get a syntax error, it's usually that. Y2 is 2.25. Okay. Okay, if I show that, you get that typed in. Calculator doing that. So I actually didn't have to adjust my window. It kind of intersected right on my screen. Did you guys get that graph? I didn't adjust my window at all from the last problem. Now, if you're in some different window setting and you're not getting anything, remember what you do. You go to second table, and you say, what are the y values? There's the y1, the 2.25. And those are like not much bigger either. Those are point. So I don't need to go up very high. They're only going up to 2.25, and this is going to 1, not even making it to 2. So my window, so I go back to my window, I want to make my y max something just like 5. 5 is fine. It doesn't need to go very high. Does that make sense how I determined that? Did you all see that? I looked back at table, and the y values weren't any higher than 2.25. So I just need to go a little more than that so I can see it. So I went to 5, hit graph. It's going to graph them both. There's y1. And then there's y2, which is the y equals. That's just a straight line. Y equals 2.25. Flat line, horizontal line. And now, if you've got the intersection on your screen, you can find it. How do we find it now? You can't just move your cursor around. That you would go, go over there. That's a really rough estimate. That won't be very close. How do you really find it? Yeah, go to calculate. Second calc. I just hit second and calc, because whenever you want the blue above a key, you have to hit second first. Right? Second calc, and then come down to intersect here. Enter, and then remember what you do there? Enter, enter, enter. Just once, twice. See how it's saying guess? That means one more time. If it's saying guess, just hit it one more time. There's the intersection. 20.62. Yeah, that's the year. The X is the year, but remember we have to do something about that. Let's go back and see if we can figure that out. So let me write down the X. So 20.62. Let's go back now. 20.62. See if you can figure out what that means about the year. So let's go up here. So X came out 20.62. Now, X is 10 in the year 2000. You know what might help? When was X 0? They never told us 0, but when was X 0? Subtract 10 from this, huh? Be 1990. 1990 they started, and then 10 years later is 2000, right? They just told me X is 10 is 2000. Well, it's helpful to go back to 0. Just subtract 10, subtract 10. 1990 is 0. So then if I'm getting 20.62 or whatever, I just add that to the 1990, because that's where it started, is 1990. You okay with the way they're messing with time? They always have a starting point, because they just want to make the numbers easier. They don't want them in the thousands. So they're saying, look, we'll call 1990 0. So if I'm at 20.62, add that to 1990. So you always have to add it to whatever X is 0. And so what is that? Is that going to be 2010.62? Right? Did I do that right? And then now, do you round that to 2011? No, remember that's late in the year 2010. Late in the year 2010. Good on that? Thorough job on that one?